They want me to explain, or everybody essentially pretty much following me. Okay, go for it.
Why is it that the received power level almost never goes over negative 50 dB? Because I've noticed that on almost any program I've used, it never goes above that except for yours right now, which is right next to the computer.
Yeah, essentially how. Essentially what Mark said, that the FCC mandates that you can't rise above a certain power level. There are certain access points that have certain firmwares that you can up the transmit power.
Yeah.
But in order to, I guess it's more for safety reasons.
If you get an external Wi-Fi antenna for your computer, you can buy those PCIe cards with the RF antenna hookups in the back. They're a little bit different because they're female connector with a male out of it. But if you can make one like I did, you can put like a 21 dBi dish on top of that, and then the gain from the ad hoc network that's coming out of you can set it up. You can get a lot of power, like way over what you're supposed to have.
Yeah.
Pick up a lot of gain from OU's network from way off campus.
That's an aftermarket mod. If you buy a router right now, you're not going to exceed that without.
Yeah, not that you're allowed to do any of that.
Yeah. We're again, this is strictly the FCC. They mandate, but if we can talk about hackery.
If I remember it, that's what the Hilton or some hotel chain got in huge trouble for broadcasting outside of the FCC specifications, and they are multi-billion dollars in suits from the FCC against the hotel chain.
Mm-hmm. Yeah, the FCC, they will come down hard on things like, if you can play around all you want in the ISM bands and you'll be fine. But other bands, FM, AM, things like that, they really do. That's why they go after pirate radio, things like that. I mean, they're unlicensed. They don't screw around. So, what in the back there?
Is channel 14 just out there?
So, channel 14 and channel 13 are not permitted for usage in the United States. I don't know exactly why, but if you buy, you go online and you buy a router that's for international usage, you can use channels 13 and 14. Just got to make sure that the FCC isn't scanning you. But, I don't know if they would find you pretty easily. It's just that FCC mandates that U.S. routers cannot have channel 13 and 14. So the ISM bands, they are unlicensed, but the FCC still puts rules on things like that. They just make it so you don't have to go through the trouble of licensing every piece of gear that operates on the ISM band. So, go ahead.
Is there any reason why everybody uses channel 111?
Yes. Aha. Good question. It's because this. I'm going to go back to this image here. F5. Derp. Okay. Oh, frick. No, it's a Windows 7 machine. So check this out. Channel 1, Channel 6, and Channel 11. What do you notice about these particular channels?
They don't overlap.
Ignoring 12, 13, and 14.
Ignoring 13 and 14, but yeah, they don't overlap. That's a big thing. The reason why, and OU's engineers are very smart, and they know this, they will not, proper network placement and channeling is that you put, for best performance, put your networks on non-overlapping channels. So let's say you're operating 3 wireless networks in your apartment. Okay, you got a 3-story apartment and you want maximum coverage. Okay, so you say, let me put a wireless access point on each floor of the house. Maybe even with different SSIDs. It doesn't matter. It could be the same. What you want to do is you set them to different channels. The Wi-Fi cards in your devices and your laptops are designed to hop channels back and forth, no problem. That's why all these OU networks you see, I'm connected to the Ohio University network, and I can walk around the building, and as long as I'm in ARC for blue socket login, as long as I'm in ARC or whatever building that I'm logged into, it'll be able to hop back and forth on these channels. No sweat. So, did I see another question or? All right, I'm going to continue rambling on. Fantastic. So yes, we've left Aurora Maiwai kind of hanging out here. Hopefully, let's see. Hopefully it's a little lower, but well, again, the transmit power is still a little bit high, but we do get spikes. That's the key thing. I'll change it to another channel, and we'll see hopefully a just flat line in here. these spikes, essentially, on the screen here, this is interference, visually what it is, that your power levels just dropped and you can lose signal. For example, like, boom, we just lost it there. And you can see the other access points, other channels kind of going crazy down here. So let me reduce the transmit power of this since it's right here. So, lowest I can go is 30%, and okay, and we're going to change the channel. Let's see, we're going to go to channel. Okay, go ahead and turn your access point off, Aaron, because I'm going to switch to channel 6, where there's not too many. So, hopefully we can get less interference. But here's the thing. So when you're designing your networks, you don't always have to put your access points on one, or your channels on 1, 6, and 11. In fact, if I'm setting up an access point right now on this network with this infrastructure, this sucks. I can't use 1 or 11. I can maybe use 6. But look, another OU network just popped up. All right. You know, these routers most likely are set to automatically jump channels. You can manually set, you know, your channel in your router. So with this, you know, this will look different than like my apartment. If I'm the only one with an access point nearby, I can put it on 6. I can put it on 11. All right, depending on the site serving. So go ahead, and I'm on channel 6 now. So here, well, I'll let it run for a little bit while I continue the lecture. So I'm almost, damn it. All right, time for demo. All right, so choosing the channel. Like I said, improper channel selection can lead to performance degradation and signal drops. So your Wi-Fi network isn't just competing with other Wi-Fi networks, as we saw here. There's probably a lot more devices that are causing interference. Cordless phones, heaters, microwaves, things like that. God knows what. So like I said, proper channel selection, it doesn't make your network faster, but it makes it more reliable. So we talked a lot about 2.4 gigahertz. Now you saw kind of 5 gigahertz earlier with 802.A and 802.11n, which is the new standard. So this is the new highs, all right? 5 gigahertz. For the reason being is that at 5 gigahertz, this essentially solves a lot of the problems that plague the 2.4 gig ISM band. At 5 gigahertz, it doubles your bandwidth. Now instead of 22 megahertz or 20 megahertz bandwidth, you're operating at a 40 megahertz bandwidth. That means you can push more data through that pipe, essentially. You know, it ups the theoretical bandwidth from 54 megabits to, you can go 600 megabits. Because now, we have a cool thing called MIMO. Who here has seen a router that says MIMO on it? Like the new fancy, yeah. Multiple in, multiple out. And it has like 10 antennas, okay? That means that you can have multiple streams of data going in and out. And every stream, and please, if there are any subject matter experts here, correct me if I'm wrong, but as far as I understand it, every stream now will increase your data rate. So if you were operating at maximum, you know, with maximum streams here, you could essentially top out at a theoretical 600 megabits. It was 300 for a while, but they broke that, and you know, the scientists, well, we're engineers, but those sciencey types have figured out that 600 is the limit. So anyway, so that's that. Now, this comes at a trade-off. Yes, Chad.
Okay. Now, of course, I'm a CS guy, not E, so I don't quite get how all this works.
Okay.
So you've got a router that's got the antennas.
Uh-huh.
And those are omnidirectional antennas?
Those are omnidirectional antennas, yes.
Okay. So...
If they're, pointing upward, that
Yeah.
signal is going to radiate like a donut, like a ring outwards.
So we've got 2 people talking to the same router.
Mm-hmm.
And so they're sharing the maximum bandwidth, you know, we're talking about the other ones.
Mm-hmm. So
when you have this configuration with, say, 10 antennas, what, if, I'm still not entirely certain what the extra antennas actually, why they make it so much better. I mean, it's like if if it had to do with like, 10 antennas and you had 10
Yeah.
people, oh no, that's better, I can sort of see that.
Right.
There's
Mark?
there's a big multi-path cancellation, right? So you have two antennas out here, right?
Yeah.
So you have a signal coming in, and it's omnidirectional from your laptop, omnidirectional from that. So what happens is you not only get the direct signal, which is, you requiring, hey, I want Google, right? You also get your signal that bounced off the wall and came back, and everywhere, everything. So what happens is with those two antennas, it does a time of arrival. So it comes in the second one a millisecond later, and it says, okay, I think this was the first signal, and then this is the next one, because it could have flipped a bit or whatever it does within the packets. So if you have a bunch of these antennas, they can also service more people too. So if you're coming from that side, right, of the room, and I'm from this side of the room, and the way that spherical wave hits the antennas is actually going to set up, okay, I'm going to service you better from this direction, and it's going to basically drop the other call into the next one, not call, but a packet request into the next antenna. So it's kind of almost like how radar spits out azimuths too, with multiple antennas, MIFSAT stuff. So.
Yeah, it's additive interference.
It's kind of neat. Really, it's interference loss.
With antenna arrays. Mark is better at antenna theory than I am. We both took the same classes, but he understood it better than I did. So, yeah, we're avionics guys. Hey, go ahead.
Well, and ultimately that would get into things like beamforming, right, where you could first analyze the location of the broadcast and receive device, and then use multiple outputs to use wave interference to actually boost signal power specifically.
Yes
to
and
that.
no.
Exactly.